Hello everybody. We're going to talk about a guide on the application of pavement design methods for low volume rural roads. My name is John Rolt, there's the title again, and we are in May 2020. The authors consist of myself, Andrew Otto, Kenneth McCurry, Sarah Reeves, John Hine, and Leah Musanero. And we had a stakeholder working group whose composition is there on the screen. The project management unit was headed by Mr. Joseph Hall, and we had two technical panel members as well. So basically quite a large group involved. Just to put the low volume roads into context, most countries define their road network in terms of trunk roads for their main roads, primary roads, and then the classes of secondary road, tertiary road, and feeder access roads as we go down in class. Obviously, the most expensive roads are at the top, and the ones at the bottom are hopefully less expensive. I put this up because it's often slightly confusing for people who classify their roads differently. In Africa, all three of the lower classes, secondary, tertiary, and feeder, are often classed as low volume roads. But in Asia, for example, only tertiary and feeder roads are called low volume roads. I don't think it's particularly important, but it's worth noting the different classes there. For pavement design purposes then, a low volume road is defined as one designed to carry a cumulative traffic loading of up to 1 million equivalent standard axles per lane over the design life. Equivalent standard axles is a unit that measures the effective amount of damage that a vehicle does to a road, and 1 million equivalent standard axles per lane over typically a 10 or 15 year period would be within the class of low volume roads. Low volume roads are constructed usually using locally available natural materials, which may be modified to meet standards given in the low volume road design catalogues. In other words, we're using materials that are not the strongest available, but we are using ones that are locally available and therefore hopefully cheaper. They don't have to be hauled a long distance and so on. And they may be unpaved or sealed with a thin bituminous seal. But we also include what we've called discrete element surfacings. These are things like cobblestones and bricks that you might want to use in a market area or in a hilly area or something else. They come into the same category too. Given good drainage and surface maintenance, which is vital, these natural materials can carry probably up to 3 million equivalent standard axles over the design life. But as I say, generally speaking, we restrict low volume roads to the less than 1 million standard axle class. The cost of providing low volume road infrastructure based on traditional standards and design methods developed for high volume roads is high. In response to this challenge, research on various aspects of rural infrastructure with the aim of reducing costs has been underway for some time. The research has concentrated on low volume rural roads, but some elements are also applicable to urban roads. This research has resulted in innovative approaches that can provide cost-effective solutions for low volume rural access through, for example, the use of non-traditional road building materials and labour-intensive construction methods. More than a dozen design manuals for low volume roads have been written in the last 15 years as part of this programme, and several different design methods have been used. This has led to a certain amount of confusion concerning the advantages and disadvantages of each design method and when and where to use them, and this has culminated in this guideline to provide guidance. A series of important decisions must be made in the early stages of the development of a rural road project. These decisions have to be taken in a particular sequence. The decision process can be developed and extended into what may be termed the pavement's life cycle. The life cycle is a framework for presenting guidance and recommendations. The road note is concerned with part of this cycle. This is a schematic diagram of that cycle. We begin with planning and go through feasibility, final engineering design. Then we build the road. It serves its purpose. It needs maintaining. Eventually, it wears out. It requires rehabilitation or upgrading. And so we go around in the cycle. Our document is concerned with the structural design. The structural design takes place in box 3 and box 6. But hopefully we'll go around this cycle. The road will go around this cycle many times in a few generations. The road note is aimed at government officials responsible for formulating policy and planning on the structural design of LVRs, engineers who are responsible for designing low-volume roads and supervising their construction, academics involved in training engineers in highway engineering, and also aid agencies who are responsible for the preparation and design of road projects. So essentially everybody involved in low-volume roads is essentially a target, an audience for the document. The intention was to produce a document that provides guidance to engineers on key aspects of pavement design for low-volume roads. In that sense, it is not strictly a manual, it's not strictly a textbook, it's not a set of specifications, although it contains elements of all three. I mention this because there's often confusion about the difference between manuals and specifications and textbooks. Textbooks are going to teach you about all aspects of a subject. A set of specifications tell you exactly how you actually construct or build something, and a manual is, if you like, more of a guidance document too. So it's essentially a guidance document containing all aspects, all those three aspects of knowledge and learning. The road note is for the structural design of low volume rural roads and provides guidance on the initial decisions required in selecting an appropriate pavement design and surfacing. The issues pertaining to the selection of an appropriate pavement design method, specific considerations pertaining to climate resilience, because as we know, the climate is changing in most parts of the world and causing quite serious problems in places. So that is an important issue in the design of the low volume roads. And of course, at the end of the day, one has to do things in the most cost-effective way. So economic analysis is required for selecting the most economic option. There'll be a number of options, and usually the least expensive one in whole life cost terms is the one that would be selected. So the different pavement design methods that I mentioned earlier that have been used before, that we are including in the road note, are these 7 different methods. The first 5 are based on what is called the California bearing ratio method of assessing the strength of materials. And these 5 are the AASHTO design method. AASHTO stands for the American Association of State Highway and Transport Officials. It is the design method is the basic American design method. And you might argue that that's probably for high volume roads, but in fact the design manual includes low volume roads as well, and low volume roads were involved in or contained in the original research on which the design method is based. The second is the TRL Overseas Road Note 31 method. This is based on a manual that was written by TRL initially in the mid 1960s, because the road networks in the countries that we were involved in were expanding, and obviously we had methods in the UK, but they were not applicable necessarily to tropical climatic conditions and the conditions of the countries we're involved in. The materials are different, the traffic levels are different, climate is different, and so on. So a specific research project was set up to develop a method of doing the designs for those conditions. That was accomplished with Road Note 31, which has been updated 4 times since the mid-60s and is still a currently used method. The third one is called Overseas Road Note 18. Now, Overseas Road Note 31 is for new roads, but as you know, many of the projects you'll be involved in will be not new roads, that they will be updating or upgrading existing roads or tracks, and the method of doing that is quite different to the way you build or design a new road. So Overseas Road Note 18 is a method very similar in principle to Road Note 31, but designed for the upgrading of existing tracks or roads. The fourth method is probably one of the newest here. It's based on another TRL study in the African region. The reason for that study was that there was a view that we were possibly over designing roads. One of the problems has always been that if a road behaves badly or fails early, the immediate reaction is, oh, it wasn't thick enough. We needed to make it thicker and stronger. So it'd been a trend for, if you like, over design. Roads were getting thicker and thicker. But when we looked at existing roads that had performed well, certainly in 3 countries in Africa, we came to the conclusion that we could, relax the specifications a bit. They didn't need to be quite so thick. They were working perfectly well. So in three countries, we did this study, and it came out with a revised design method. Again, quite similar to Road Note 31, but with slightly different outcomes. And the fifth method that we've called the foundation class. This, in a way, is similar to the others, but the main difference is that instead of building just on the subgrade that you've got, you actually make a foundation which you use for all subgrades. So you've got a standard foundation. This has its advantages, as you'll see when we come to the discussion of the different methods. The second group of methods is called the DCP-based method. The DCP stands for Dynamic Cone Penetrometer, and that is a different way of measuring the strength of materials to the CBR method. It has its advocates. It's one of its great advantages is that it's very quick to use, so you can take a lot of readings, but and it's being adapted for the so-called DCP design method. And there are 2 methods that use the DCP. One is a pure DCP method, number 7. Number 6, the DCP results are converted to CBRs through a correlation. So there are two additional methods based on the DCP. So all of these 7 methods are discussed, and their pros and cons, advantages and disadvantages are discussed. Now, one of the key issues about low volume roads is that all roads carry a risk. The weather, the climate can be very adverse. The vehicles can be very overloaded and cause damage and so on. So, definition, low volume roads do not carry high volumes of traffic, but they do occasionally have to carry heavy vehicles. The traffic stream will contain up to about 30% heavy vehicles on what we call low volume roads. And of course, it's very difficult to control that overloading or those heavy vehicles. Some countries have tried to prevent overloaded vehicles from travelling on the rural roads, but it's generally not been very successful. So there's always a risk that our low volume road will have to carry a few heavy vehicles, especially, as I've said here, during harvesting season. Add to that also any season where people are building materials are heavy and so on, and logging is another process that actually causes vehicles to be heavily loaded. So there's a risk of high volumes of high levels of overloading, and there are risks of climate. And of course, the low volume roads are constructed from materials that do not need to be as strong as those used for the high volume roads, because we want them to be less expensive. Their performance is actually largely governed by the environmental factors, because, as I say, we're really hoping or expecting them not to carry too much heavy traffic. So the next slide shows schematically what is happening. The traffic is along the bottom axis here. 1 million standard axles is in the middle. And as you can see, what we've shown here is that as you go up in traffic, the traffic becomes the most important factor in controlling the performance. But when we go to lower traffic levels, the effect of traffic is less, and it's the environment that controls the performance of the roads. So essentially, there's two different areas of interest in terms of how you design them. We're designing for heavy traffic here. We're designing to control the environmental aspects down here. That's the fundamental difference between the high volume and low volume roads. The objective of the guideline is to provide road practitioners, including non-engineering decision makers, with a practical source document on selecting the most appropriate pavement design method for LVRs for each situation, which is authoritative and contemporary. It defines key issues and clearly signposts procedures that may usefully be followed in order to respond to regional and user-specific challenges. The guideline is set within the principle that the roads should be designed to be compatible with the local governing factors. Roads are designed for a long life, but they deteriorate with time and traffic, and they require repairing or rebuilding. Thus, the life of the road can be described as a pavement project cycle, as shown before. So the road note caters for a range of real road types, from the basic earth tracks to bituminous sealed roads, and includes roads surfaced with what we call discrete elements. These are things like cobblestones and block paving, which you might want to use in a market area through a village or whatever, or in a hilly area or so on. So where the need is such that you need them, the manual, or at least the guideline, will show you how to do the designs. The road note does not deal specifically with urban roads, but some aspects, for example, the structural design of road sections themselves, are equally applicable in urban areas. There's obviously a lot of other differences between rural and urban, but the structural design is one that's fairly similar. So the guideline will deal with the structural design of some aspects of in the urban areas. The contents, this is a list of the chapter headings, basically. I'm not going to go through each one. We'll very briefly summarize them in the next slides. The road note is organized in such a way that key considerations that are common to all pavement design methods and have a strong bearing on the performance of any design, such as drainage and climate resilience, which is in chapter 2, and selection of materials in chapter 3, are discussed first. Chapter 3 is concerned with the characteristics and specifications for the materials for constructing the road. Chapter 4 presents the background to all of the pavement design methods, and those methods are described in detail in chapters 5, and the design of both minor and major gravel roads is discussed in chapter 6. There are numerous different surfacing suitable for low volume rural roads, and the selection of these form the content of chapter 7. Chapter 8 discusses economic analysis for the comparison of different pavement design options and different methods of economic analysis. Factors that affect the performance of pavements are discussed in a general context in chapter 9. Obviously, this is not a design manual for every aspect of low volume roads, but there are some factors within within the context of designing low volume roads that are extremely important as they affect the structural design, which is the main subject of this guideline. So some of those factors are discussed in a general context in Chapter 9. This includes ground improvements, slope stability for cuttings and embankments, borrow pit management and compaction, as far as for helping get the quality of the materials better. In addition, guidance is provided on how to integrate the results of recent research found in existing other manuals. So as you know, as I've said, we've got a number of manuals that have been written in the last few years that also provide information that can guide you. So in summary then, the Real Road Note is applicable to a wide range of countries, and therefore it would be impractical and inappropriate to provide recipe solutions for specific situations. Instead, the emphasis has been placed on guiding the practitioner towards evaluating alternative options and considering their application and limitations as a basis for making a decision on region-specific situations and on a project-by-project basis. In other words, it's a very wide-ranging guideline and should be applicable in many countries. We've achieved this, I think, by collating together in one document guidance on the application of tried and tested methods of pavement design, plus new and innovative solutions that have come from the recent research studies that I mentioned at the very beginning. Okay, thank you for your attention. That is the end of the presentation.